If you have any doubt in any chapter, then please let me know. I will just clear your doubts.
I think I'm good.
Okay, so we'll practice some questions on the chapter redox reaction. Is it fine?
Yes.
So can you see my screen?
Yes, I can see a screen.
Yeah. So in question number 7, you have to tell me the oxidation number of the underlined elements. Let me zoom it out. Oxidation states in a formula, it adds up to 0. This is the rule of your oxidation number. So you have to tell me the oxidation state of the underlying atom in the formula given below. Like for aluminium oxide, you have to tell me the oxidation number of aluminium. Similarly, you have to solve in ammonia, you have to tell me the oxidation number of nitrogen. So,
Done.
The oxidation state of aluminium in aluminium oxide is
+3.
yes. Of nitrogen in ammonia
It's +30 also.
+3 also.
Yeah.
Look again.
Nitrogen in group 5.
Yeah, but which is more electropositive? Hydrogen is more electropositive than nitrogen. Nitrogen is the most electronegative element.
Oh yeah. So -3.
Yes, it is -3 because nitrogen is more electronegativity of nitrogen is greater than hydrogen. Okay, so hydrogen is +3 and nitrogen is -3. That means hydrogen is +1 and nitrogen is -3. Of carbon and carbonic acid,
Carbon. It's +3.
+3. Let us solve 2 for hydrogen and +1 is the oxidation state of hydrogen. Plus we don't know the oxidation state of carbon, so we write it as X. Plus there are 3 oxygen atoms and the oxidation state of oxygen is -2 is equal to 0. Then 2 plus X minus 6 is equal to 0. Then X minus 4 is equal to 0. So the oxidation state of carbon in carbonic acid is +4, not +3. Okay.
Okay.
Yeah. Of phosphorus in phosphorus trichloride,
It's +3.
yes. Copper in copper chloride,
+1.
copper in copper chloride,
It's +2.
so you can see here 2 compounds. In copper chloride, copper has an oxidation state of +1, and in copper 2 chloride, copper has an oxidation state of +2. It means that copper can exist in multiple oxidation states because it is a transition element, and transition elements show a variety of different oxidation states. Is it clear?
Yeah.
Now solve question number 5. Chlorine gas is bubbled into a solution containing sodium bromide. The reaction is given to you. So you have to answer all these questions, whatever they are asking. So please try it.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Let us solve now. So the question is that chlorine gas is bubbled into a solution containing sodium bromide. The equation for the reaction is given to you. First question is that chlorine takes the place of bromine in the metal compound. So what is this type of reaction called?
Displacement reaction.
Yes, it is called a displacement reaction. The compounds of group 1 metals, they are white and they give colorless solution. So what would you see as the above reaction proceeds?
Would see the solution of the bar solution. The bar solution would turn from from brownish to white.
So brownish is this gas and colorless is this. Okay, because this is your what solution? It is your group 1 metal solution. It is your white color and they give colorless solution. And the color of bromine is brownish gas. Okay, brownish orange. So you will say not brown to colorless. You have to say that changing color will observe the change colorless sodium bromide solution. It will turn brownish orange due to the formation of bromine. Okay.
Yeah.
Write a half equation for the reaction of chlorine.
I said it's C minus in aqueous Na plus aqueous to form NaCl. Aqueous.
Don't involve Na here because you have to write half equation. In half equation, you generally don't involve the spectator ions. So tell me only the chlorine part.
We Cl aqueous plus E minus to form Cl.
This
Aqueous, yeah.
chlorine never exists as a single element. It is a diatomic gas. It always exists as Cl2. So you have to add Cl2 here. Okay, Cl2 plus electron. And then to balance the equation, because there are 2 chlorines on the left hand side, you have to write down here 2Cl minus. And since one chlorine have one, the valency of one chlorine is 1. Okay, since there are 2 chlorine involved, so you have to write 2 electrons here. So the equation is Cl2 gas plus 2 electron, it gives you 2Cl minus. Okay. Because this is my chloride ion, which you are saying as NaCl. Okay, this is chloride ion, and chlorine always exists as a diatomic gas.
Okay.
Is the chlorine oxidized or reduced in the reaction?
It is oxidized.
Is it gaining electron or losing electron?
It's losing an electron.
Gaining electrons, right?
I thought it's losing an electron.
Cl2 plus 2 electron, it means it is gaining an electron. If electron comes on the right hand side, then it is losing an electron. But if it comes on the left hand side, then it is gaining an electron, right? And obviously the electronic configuration of chlorine, okay, not this one. So here what we are happening, chlorine is gaining 2 electrons, because if you write the oxidation state of this equation, then Cl2 is 0 because it exists in the elemental form. And here if you see NaCl, then in chlorine you have -1 oxidation state, and in sodium you have +1 oxidation state. So chlorine is oxidized or reduced from 0 to -1?
It's reduced.
Yes. So the answer is reduced, not oxidized. And obviously it is gaining electrons. I hope you know this oil rig, where oxidation is the loss of electrons and reduction is the gain of electrons. Now tell me the half equation for the reaction of bromide ion.
Okay. 2 plus 2E minus. So it's Br minus to form Br2 plus 2E minus.
Is the equation balanced?
Oh, supposed to be 2 Br minus.
Yes, now it is correct. Reactive elements have a strong tendency to exist as ions. Which is more reactive, chlorine or bromine?
It is chlorine.
Yes, chlorine is more electronegative. Why? Because chlorine is having smaller atomic radius, so it has greater attraction of electrons. Therefore, it gains more electron radius. Which halide ion could be used to convert bromine back to the bromide ion?
It's iodine.
Hmm?
Iodine.
Iodine, no, it is asking which halide ion.
Oh,
Iodine,
iodide.
no, iodine is less reactive, so how can it will displace bromine?
I thought it
Yeah.
was bromine back to a bromide ion.
Yes. So you have to convert bromine back to the bromide ion. That means you have to, right? You have to do this reaction, bromine back to the bromide ion. Okay, bromine back to the bromide ion, Br minus. So which halide ion is used here? You have to see this reaction which is in the question. Let me raise this. In the question, the reaction is that chlorine, it reacts with sodium bromide, that means bromide ion, to form bromine and chloride ion, right? Now, opposite thing we have to answer here, that bromine, you have to convert bromine to bromide ion. So which halide ion should be used?
Shouldn't it not be an iron which is more which is less reactive than bromine?
So what is the reactivity order of halogens?
They reduce as they go down.
Down the group.
Yes.
They decrease down the group or increase down the group? The reactivity decrease down the group or increase down the group?
They decrease down the group.
Yes, fluorine is more electronegative, then chlorine, then bromine, and then iodine. Okay. So now answer this question. Which halide ion could be used to convert bromine back to the bromide ion and write the ionic equation for this reaction? Think about it. You have correctly told me the reactivity order: fluorine, chlorine, bromine, and iodine.
Yeah,
So you have
and
to
I said
convert.
the answer is
Yes,
iodine or iodide.
answer is iodide. Okay. So it should be I minus, right?
Yeah.
Okay. So this should be the ionic equation. Is it correct? I minus plus Br2. It gives me Br minus plus I2.
It should be 2I minus and 2Br minus.
Yes. Okay. Now solve this question number 8. The oxidizing agent potassium permanganate can be used to analyze the percentage of iron present in the iron tablets. Below is the ionic equation showing the ions that take part in the reaction. So you have to answer these questions: color change and the oxidation state and the half equation.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Okay, so what does the H plus in the equation tell you about the reaction?
It tells us that it is an acidic reaction as
Yes.
ions are released.
Yes. The presence of H plus, it indicates that this reaction it is carried out under acidic conditions because H plus ions are there. Describe the color change.
The color change goes from a purple solution to a colorless solution.
Yes, because these MnO4 minus ions are purple and Mn plus 2 is colorless. Which is the reducing agent in the reaction?
The reducing agent is the Fe, the iron 2 ions.
Yes, iron 2 plus is the reducing agent. How could you tell when all the iron had reacted? That means the completion of the reaction.
We will see a color change occurring.
Yes, the reaction is completed when the purple color of your potassium manganate solution disappears and we have a colorless solution until your Fe plus 2 ions they have been completely oxidized. Okay, write a half equation for the iron ion.
It's Fe2 plus Fe2 plus to form Fe3 plus E minus.
Yes, plus electron. Okay, so we have done this question also. Question number 6, you can take the screenshot, practice it at your home. Question number 10 also. And question number 3. Done?
That's it.
Okay. So, all right, that brings us to the end of today's session.